This problem will show you how to solve some of the homework problems for modeling. We will look at problem number, we will look at problem number 54, chapter 4 homework, which is on modeling. The problem says that the table below shows the weight in pounds for a dog, the different amounts of days since its birth. The first thing we'd like to do is we'd like to use technology to create a scatter plot for this data. We're going to go first show how to use Desmos. The nice thing about Desmos is I can actually, as long as I'm in a Word document, I copy the values in the table and I can go in Desmos. Just to get to Desmos, you just type in desmos.com. And up will pop it. If it doesn't pop this up right away, you can just type graphing calculator. Then I can just paste this data set in. Nice thing is that it will actually fit it for your data set. So it actually puts it in exactly as the data is, exactly as you'd like to see it. If you don't like this one and you'd like to see a little bit better, you can actually go to the icon that looks like a wrench. It's called graph settings. And you can change these. So if you don't want to see so much negatives, we don't need negatives because we're looking at dates since birth. So we can change this. And I like to have a little bit, so I might make it -1 so I can see this axis a little bit. I probably don't need to go up to 1962. It looks like 1400 might get me as high as I need to go. Then my y-axis, again, I don't need to have all this blank space down here. So I'm going to go to maybe -1 so I can see the axis here. And then maybe go up to, it looks like 90 might be enough. And there it is that way. Now looking at this graph, it looks like we're coming up a bit, then going and flattening out. So it looks like we're starting off exponentially, but then it looks like it flattens out a little bit. So that makes me think logistic might be the better model for this. Desmos needs me to put in what that model looks like. So I need to know kind of what the shape of that model is and what the structure of it is. So if you go into the chapter 4, into the growth section, 4.5 for this book, you'll find different models we can go through. We can do linear, exponential, logistic, parabolic, cubic, and periodic. We want logistic because we think this looks like a logistic shape. So this is what the basic shape looks like. You've got your function is equal to m over 1 plus k e to the -ct. So it looks like that might be the right model we're going to try. So we're going to go into Desmos, we're going to type that in. So go down to a new space in Desmos. I'm going to type in y, and I do want a y1 because if I look up in here, these x's are x1 and y1. So I want this to be y1. So if you type a y and then a 1, it automatically makes it into a subscript. Then I need to put a tilde or tilde. And the tilde or tilde is on the top row next to the number 1 key. You have to shift to get to the tilde, but there it is for you. And then you're going to type in basically this basic idea. We had m, and you can actually use m divided by, you just use the slash for that, 1 plus, and it was k, so I can type in a k, and then e to the negative, and the negative to the is actually a caret, so I'm going to use low caret, and then negative c t. I can't use t because if t wasn't my variable. My variable is x1. So I need to actually use x1. So I'm going to type in an x1. And again, if I just type an x and a 1, it puts the subscript in there for me. Notice once I did that, it does a nice graph for me. It says, hey, this is what the graph looks like. If I look at this, it seems to follow the data pretty good. It's not perfect, but it does a pretty good job. Data is never going to be perfect. This is dog's weight, by the way. So, you know, some dogs, they eat less 1 week or more a different week. So that's why it could look that way. If I look at this, it tells me my parameter values. It tells me my M is 71.57. Tells me my K, by the way, that's your carrying capacity. Tells you your K is 11.7. Tells you your C is 0.017. The M of being 71.571, that's your maximum that the weight should be. Doesn't mean that's what it will be, but that's the maximum that it probably should be if the dog was eating healthy and everything else. We also have an R squared value. This is our coefficient of determination, it's called. We call it just the R squared, and here it tells you how well does the model fit the data. So 98.67 is pretty dang good. You don't happen to have an 80 a Desmos, you want to use your calculator, you want to use your TI calculator, we can show you how to use that also. So here is the calculator. I do need the data up because I need to type it in. Unfortunately, as opposed to Desmos, I have to type this data into the calculator. So to do that, I'm going to go over, there's lots of different menu buttons on the calculator. The main menu button I want is the STAT button. It stands for statistics. We're basically doing statistics to do a regression model. So we're going to go in here. These have submenus: edit, calculate, test. These are the submenus we have. We want to be in the edit menu, and we actually want to edit because we want to put the data in. So number one is where we're going to edit it. I have some data in here already. I don't want that data. I don't need that. So I'm going to hit there and go up onto the name of that letter, that column. Notice the columns are called L1, L2, L3. I'm going to go up to that one, L1. I'm going to clear it out, hit enter, and it just clears the whole data set. I arrow over, go up to this one. I hit clear and enter, and that one's all gone. Now I can type in the data values: 31, 62, 93, 99, 107, 113, 121, 127, 148. I don't need to say them each time, but it helps because I just noticed I did 161 there and I didn't type 161, I typed 16. So it helps to kind of say them. I also notice I have a 14. I don't have a 148. So do be careful when you're typing these in that you don't type them in wrong. And make sure you type them in the order they're in. So don't change the order. 214, 221. So check them as you do them to make sure that you don't do any wrong. Whoops. 452, 482. And this is the problem, of course, with the graphing calculator, is that you have to type them in, and so you can easily make a typo. So do check your numbers. If you arrow over, you can start at the top of the next row. You do want to start at the top and put them in order because these are ordered pairs. You want to keep them together. They belong together. Think of it as that they're married. Again, make sure you've got them all right. You didn't make a mistake when you typed them in, like I just did there. So. Next one is 48.7, 54, 54, 63, 66, 72, 2.2, 76, and 75. So again, make sure you didn't type it in wrong because if you made a mistake, you're going to find that out. Now, if you want to graph it, I do want to graph it. This first row here is all the graphing we have on the graphing calculator. We want to do a statistics plot. So we're going to go to this one that says stat plot. Notice it's in blue. It's above everything. So it's a second. So you hit the big second button. Happens to be blue. Yours might be yellow. Depends on what it is. And hit that Y = 2 button. Gives you the stat plot. You've got different stat plots. We want to just go into number 1. Turn it on by hitting enter on the word on. The default is a scatter plot. Default is L1 and L2. You could have used any of the columns, but I like to use the default. The marks, you can either pick a square, a plus sign, a dot. You might have a bigger dot. I like the plus sign. I just think it's just the one I prefer, but you can use any one you want. Now I need to go ahead and set my window. The easiest way to do that is go into the zoom button. Again, everything's in this top row. And the very bottom one says number 9, says zoom stat. That means it will do it for your statistics. You can either arrow down to number 9 and hit enter, or you could just hit the number 9 button, whichever way works for you. And there it plots up. You can see a nice graph of it. Again, it kind of looks like a logistic model. So it looks like that's what we want. On my graphing calculator, I'm going to go to stat again. I'm going to move over to the word calculate. This is where we calc. So calc stands for calculate. This is where we do all the calculations. It's got a few things we don't need. ln reg is the linear regression. Quad reg is a quadratic regression or parabolic. Cubic regression, quartic regression. There's a second linear regression if you like ax plus b or a plus bx. ln regression is the natural log regression. That's different from a logistic, by the way. exp is the exponential regression, power regression. My calculator has a newer software, so it has a logistic one. Yours may not. If yours does not, you cannot use your graphing calculator, and you will need to use Desmos for these. I'm going to go ahead and enter. And then here's my L1, L2. It'll automatically default to L1, L2. That's why it's better to use those. There won't be a frequency list, so don't worry about that. But I would like it to store this equation. The way I can do that is go down to the word store, REGEQ, which is regression equation. There's a button that says VARS, VARS. Press that VARS button. Again, there's different submenus. We want to move over to the YVARS. Number 1 is for functions, and then we want to put it into Y1. All this is going to do is tell the calculator that when you calculate it, put it into Y1. Then go down to the word calculate and hit enter. It will then put that on your main screen, then it will calculate it, and it tells you what its general formula is. It's slightly different than the one we had in the book and the one that Desmos used, but it's the same form, it's just used different letters. It uses a C instead of an M, an A instead of a K, and a B instead of a C, but otherwise it's the same thing. And there's my equation. The thing is, logistic will not give you the R² value, so you will have to use Desmos to get that. Now you can go ahead and write down your equation. So I'm going to actually write this equation. So sorry about my handwriting. So I've got y equals, and y is equal to the dog's weight. And so just so I don't have bad handwriting, I'm going to go ahead and do this way. Dog's weight. And then my other variable is t for time. T equals the number of days. And then I can go ahead and write my equation. So my equation is y equals, and I want my C value, which is 71.6, let's say. Over top of, it puts it this way, but it's better to write it with an over top of as a fraction. Then 1 plus my C, sorry, my A is 11.7. And then E to the negative B, and my B is 0.017. Instead of using X, they used X here, but I want to use T because T for time. I'm going to put a T there instead. So that was the next thing that the homework asked me to do. So the homework asked me to use technology to create the data plot, that scatter plot, which I did. I then decided from that scatter plot, it was a logistic. I then used technology to come up with my model, which was logistic. I'm then going to determine my R² value, which again, I need to do from Desmos. So R² can actually be calculated for linear regression, exponential regression, quadratic regression on the TID3, but it doesn't do it for the logistic and the sinusoidal one, the parabolic one. So unfortunately, you need to use Desmos if you have those kind of models. But Desmos is free to everybody. But here's my R² value. It's 0.9869. So over here, I can write down now that my R² equals, and again, I'm going to type this so that you don't have to see my bad handwriting, is 9.98. And I can't remember what I just said it was. So let's go back and just check Desmos again. And it's 0.987, let's call it 0.987. And what this means is we also want to explain this value, and it means that 98.7% of the variability of the dog's weight is explained by the model. I'm kind of surprised it's that high, because that means a lot of it, that like 100% would be tapped. 98 is pretty close to 100%. I think the other things that go into your dog's weight, like how much they actually eat and how much you actually feed them and how much exercise they get. But we're going to go with this right now. All right, so the next thing the homework asks us to find out is the homework also asked us to use the model to predict the weight of the dog at 2,000 days since birth. So we're going to explain the value that you obtained. All right, so we're going to go ahead and do that next. So the nice thing about the advantage of the calculator is I actually already put the equation in here. In fact, the equation is right there. If I hit graph, there it is, fitting nicely with that equation. And I can actually have my calculator put the value I want to put in into this equation for me. The way I do that is go to the main page. So do the big second button and the quit button. That will quit you and get you to the main page. Then I want to take and use my variable. So I'm going to go Y. I'm going to hit the vars button again. Move over to the Y vars. Pick number 1 function and pick number 1 Y1. This is function, and I can actually use function notation, which, remember, function notation is F of. So I just put a parenthesis and I can type in my 2000 right in here inside those parentheses. And what this will do is whatever you stick in those parentheses, it will stick into your X value in this equation. So that's what I've done, is whatever I put in this parentheses, it'll put in there. I want to do it for 2000, and it comes out with the answer. And it says 71.757 or 71.6. So we'll come back over here. Again, I'm going to type. So after 2,000 days, the dog's weight is 71.6 pounds. Now notice that that's pretty well close. That is in fact my carrying capacity. That's what numerator is, your carrying capacity. That's the maximum that dogs should get to if it's healthy and eating right. So that means this dog is basically at that value. Now 2000 is outside the original data. If I look at my original data only went up to 1308. So this is an extrapolation. So the dog's weight probably isn't exactly this value. It's probably not perfect. But what I would say is that the dog's weight is approaching the 71.6 pounds, that carrying that maximum it should get to. Now, of course, if you overfeed your dog, or your dog doesn't get enough exercise, or you underfeed your dog won't have this weight. But that's conceivably what the weight of the dog should be.